Welcome to the Components of Internet of Things course.
Welcome to this course on IoT components, and this is the first lecture where we have taken up a very important side of the Internet of Things landscape, which is the relationship of artificial intelligence and Internet of Things. We are calling this topic as AI-IoT synergy. Now, as is well known, IoT gives a very interesting view of the world where every object is connected to every other object through sensors and communication. It is known that these sensors would sit on the devices, for example, refrigerators, fans, and so on. And these devices will interact with each other to create what is called a smart environment. Now, the word smartness means that the systems have to be intelligent, and the intelligent behavior emerges from lot of processing of data, information, knowledge, lot of very sophisticated techniques applied on this data. The devices generate data, consume data, their interaction produces data, and to make sense of all these data to achieve interesting goals, artificial intelligence forms an important component of IoT. Let's proceed with the material of the lecture, namely AI-IoT synergy. I am Pushpa Bhattacharya, part of the Computer Science and Engineering Department at IIT Patna. First of all, it is pertinent to talk about the nature of AI. Artificial intelligence consists of many sub-areas, all of which are extremely useful, complex, intellectually rich. This is a traditional view of AI where there are two concentric circles. The inner circle consists of topics like search, reasoning, and learning. These form the core of AI because all other areas of artificial intelligence draw from these core areas. So if I take the areas on the outer periphery, natural language processing, robotics, computer vision, expert systems, information retrieval, planning, all these are activities which are at the interface of human life and computation. If I take natural language processing, the field is concerned with making computers understand and produce language, analysis and synthesis of language. It is not difficult to conceive of the relevance of language processing in the context of IoT. It should be possible for human users to interact with the whole IoT ecosystem in their own languages, in natural languages, and this brings to the fore the need for language technology. Similarly, other perceptual mechanisms like computer vision, speech, they also are human capabilities of producing and assimilating knowledge, which are very much relevant in a world of connected devices and connected beings. So these areas make use of search, reasoning, and learning as fundamental techniques. A robot, for example, will have to search its path going from a source point to a destination point. So this two concentric circle view of AI is the textbook description of AI, which has stayed and whose relevance has never diminished. A more elaborate view of AI is shown here, where uh, on the left we see broad topics like machine learning, natural language processing, speech, vision, planning, expert system, and robotics. So these areas are fleshed out with more details. For example, machine learning has deep learning and predictive analytics. Deep learning is a technique. Predictive analytics is both a technique and an application. For example, one would like to predict the trend in the stock market, the movement of financial system. So that would be application of machine learning to financial domain. In natural language processing, we see translation mentioned. In this global view of the world, people need to understand each other, cross the language barrier, which underlines the importance of translation. However, the translation system is not restricted to only human languages. Any mapping is actually a translation from an input form to an output form. Coming to the scenario of IoT, for example, the interface of a fan processes information in its own specification, in its own language, so to say. Refrigerator, on the other hand, has another interface, and the information flow from the fan to the refrigerator would require translation from one framework to another, one format to another. Similarly, speech has broad areas like ASR, speech to text, TTS, text to speech, computer vision as image recognition, machine vision, shape from shading, occlusion study, and so on. Planning, scheduling, optimization is extremely relevant to robotics. Classical planning was based on logic. Modern days planning is statistical and optimization based. Also, probabilistic planning is very successful. Expert systems mimic the expertise of a person, a professional, for example, a doctor, and it is based on huge number of rules. The rules can be acquired by machine learning and converted into a structure from which the expert can get help. Robotics similarly is used in, for example, dangerous environment like deep mining, and also in hazardous environments like fire, for example. So they again require interaction with other devices, for example, uh, the 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 pump, hose pump that is used for uh, eliminate for dousing out the fire would interact with a robot through the platform of internet through sensory mechanisms. So this is a view of artificial intelligence, its sub areas, details, all of which are important for an IoT based worldview. Now it is important to understand that artificial intelligence is all pervading, and all areas of human life, all activities of human beings can involve AI for more intelligent and efficient processing. Artificial intelligence is manifested through computational mechanisms, and therefore AI is a computational lens to things that happen in the world around us. I can divide the intellectual activities of human beings into four broad categories: natural sciences, which involve physics, chemistry, biology; humanities and social sciences, which study psychology, philosophy, political science, sociology, and so on. And more abstract things are mathematics and computation, which provide tools and processes for natural sciences and humanities and social sciences. For example, natural language processing can be looked upon as a computational lens to linguistics, where the properties and structures of language are converted into algorithms to be processed by computers. Now, this point of lens is an important point. Here we see an example of humanities and social sciences lens on natural phenomena. Here is a piece of poetry by Walter de la Mare, which describes a moonlit night. The moon is slowly traversing the firmament, the sky, and as it moves, everything below on the earth becomes silvery under the moonlight. So the trees, fruits, the paws of the dog, the water, all of them are silvery. It's a beautiful work of art, a beautiful object created through language and words and rhythm and the music. But the underlying phenomenon is a very simple one, which is that moon has a silvery light. So humanities and social sciences lens on a natural phenomenon is producing a beautiful work of art describing the moon's influence on the earth below. The complementary situation also exists. This is natural sciences lens on human phenomenon. Here is the picture of a person who is angry, and a scientific study of anger says that anger produces changes in physical conditions. It increases heart rate, elevates the blood pressure, increases the level of adrenaline, noradrenaline, and anger is also a trigger to fight or flight from the situation. So this is a scientific description of a human phenomenon, and we have an example of natural sciences lens on human phenomenon. The relevance of making this point is that Internet of Things is an heterogeneous, connected view of the world. Devices and entities interact with each other, and this is necessarily multidisciplinary effort. Different techniques and scientific knowledge are brought to bear in orchestrating an Internet of Things situation, and therefore different lenses are required to understand the phenomena and process them. Now, the main challenge of artificial intelligence is the problem of ambiguity. And first, I illustrate the problem of ambiguity through the phenomenon of language. There was a cartoon in Times of India on 25th May 2017. A person is interacting with a minister, giving the minister the information that there is heavy firing, and the minister says in which sector. So the image that comes to our mind, that is conjured up in our mind, is that of a war front. But the person's answer comes as a kind of surprise. The person says the firing is in the IT sector. That means the IT personnel are being laid off. So here is an example of a humorous situation where the expectation has been thwarted to produce a completely different conceptualization. So this is due to the ambiguity of the word firing. Firing can mean actual exchange of gunfire, or it can mean laying off of employees. So the humor and the dramatization of the situation comes from the ambiguity of the word firing. Then a very prevalent situation is that of sarcasm, where people intensify their sentiments through the instrument of sarcasm. In sarcasm, the ambiguity situation is that the surface meaning is different from the intended meaning. So here is something from a tweet. Thank you for sending my baggage to Hyderabad and myself to Delhi at the same time. Brilliant service. So the passenger is clearly angry with the airline service. It's for Indigo, I believe. And his baggage and he landed at two different places, Hyderabad and Delhi, which is causing him frustration. But he is expressing it through an apparently uh, uh, praise, an apparent praise, which is brilliant service, and that's a sarcasm. And in WhatsApp, we do see the play of words. Power department says that we will be delighted for your timely payment or tariff, else you will be delighted. So here there is word of play, and it is making the situation more dramatic. Delighted and delighted are play of words. So all of them make use of ambiguity. Ambiguity is not the prerogative of language alone. We do see ambiguity in almost all situations. Here is an ambiguous picture, very well-known picture, which is the picture of a rabbit if you look at it from the right-hand side, and the picture of a long-beaked bird where you look at the picture from the left-hand side. The eye, of course, is shared by both the bird and the rabbit. This is a classic picture which is an ambiguous situation with respect to rabbit-bird identity. Now, machine plays a very critical role in organizing artificial intelligence on any platform. It could be as complex as IoT, or it could be a very simple device like a phone which understands our speech, for example. So the ambiguity has to be resolved at every stage. We are amazingly capable of resolving ambiguity from our knowledge base and from contextual clues. Human beings are extremely resilient against ambiguity. However, computers are not so, and we need to do ambiguity resolution for computers or give them that ability. So ambiguity resolution is actually a classification problem. There are many options, and ambiguity resolution demands that we pick up one of the options. So this is in the purview of machine learning now. AI ambiguity resolution is done by machine learning through training and through accuracy improvement, through lots of error analysis on the trained machines. Now in ambiguity there are multiple classes. For example, if you remember the picture of rabbit and bird, which was an ambiguous picture, there are two decisions, bird or rabbit. So this has to be disambiguated from the contextual clues. If we, for example, give more details of the picture in which this particular segment of the picture appears, for example, we show the background of sky and clouds and flying objects around, then we may possibly decide that the picture is that of a bird. On the other hand, if it is on, let's say, green grass and lot of foliages, vegetations around, then it could be the picture of a rabbit. So the point I'm making is that ambiguity resolution is done by making use of clues from the context, and that is the job of machine learning. So this ambiguity is resolved by choosing one from amongst the available options. The option which has the highest score is chosen, and that score is often in terms of probability. So probability and statistics and data play a very important role in today's artificial intelligence. Now one might wonder, how can probability really help me? For example, I'm in an IoT situation, and from my office I want to switch off my fan. I suddenly remember that the fan was not switched off when I came to the office, and I would like to do so from my mobile. So a particular instruction has to travel through the platform of IoT to the fan. Now, if that situation is probabilistic, will it help me? Because ultimately I have to take an action on the IoT platform. That action is chosen from amongst many options, and the one which has the highest probability is the action that is finally chosen. So probability is essentially a scoring mechanism. We are not saying that probability is keeping everything uncertain. No, the action has to be certain, and the action which is the winning action out of all the multiple ones is the one whose probability is the highest. Now we slightly digress and come to another discussion which is on startups. So I have chosen this particular discussion deliberately. The reason being that artificial intelligence and IoT, the main energy givers of these endeavors are really the startups, the small industries which are seeing a need, identifying a need, and with a low entry barrier are addressing those needs. And that is happening very rampantly, very abundantly in the field of AI in particular. That is because lots of data has become now available, and there is a lot of sophistication in machine learning techniques which can process this data. There is huge improvement in systems, the speed of computer, the operating system optimization, programming language optimization. All these factors have come together now to make AI a very, very feasible proposition on an extremely powerful platform like IoT. So startups are very interested in AI and IoT because they see extremely useful applications which can have a lot of traction, a lot of monetization, and a lot of impact on how we live our life. So though there are many, many startups, we do see a few common themes. One of the most common startup themes is prediction. Prediction of problematic instances out of a conceptual space. For example, predicting if a loanee will turn out as a defaulter for a bank. So HDFC Bank is giving home loan for a person, and would like to make sure that this loan will be repaid. So the person will not be a defaulter. An organization will fall into a financial distress or not. A rentee will prove bad for Airbnb. Airbnb, as you know, is a kind of matchmaker, persons who want a short stay option after going to a country. This person is matched with available options for renting a place for a short time. So they would also like to make sure that this rentee will not damage the property, will not cause any chaos in the premises. So this is prediction based on the data, previous behavior. Lots of embassies you make use of AI machine learning to predict if a person can be given visa safely or not. So the input for such prediction problems are almost always in the form of text, image, and reports. For example, there could be press reports, personal history, Facebook navigation record, bank statement, annual report, etc. And natural language processing and machine learning come together to make useful predictions on this person. And one can easily see that if there is very little data, such techniques will not be robust, their findings or conclusions will not be trustworthy. On the other hand, as the data accumulates and becomes larger and larger, these techniques make extremely accurate and useful predictions. As for example is your experience with Uber or maps.google.com or Make My Trip and so on. These situations are winning situations. The more they are used, they become better because of the accumulation of data. So this one theme was that of prediction, and prediction is extremely important for any kind of artificial intelligence problem. Prediction is also important for Internet of Things because the framework has to behave intelligently. Another common thing, I can call this as matchmaking. So we have services like cars, shops, movies, airlines, medical professionals, tutors, bookshops, etc. And there are people who want this service. There are travelers, consumers, moviegoers, restaurant goers, readers, students, patients, etc. And we would like to match the service provider with the service demander. And this matchmaking has to be done with high accuracy and high efficiency. To take a very specific example, suppose I am at Patliputra, which is a very busy location in Patna, and I would like to go to Gandhi Maidan as quickly as possible. I engage Uber, and I have downloaded the Uber app on my mobile phone. Uber drivers also are registered in their platform. Uber itself doesn't have any cars, it doesn't own any cars, but the person who wants the car service and the car drivers who can provide this service are brought together by the Uber platform. This is an example of matchmaking. Similarly, there are matchmaking platforms in the literal sense for marriage bureaus, for example. And people who want to see movies, want to get their ratings, people who want to go to restaurants, want to get their ratings, and so on. So this is another very common theme where startups are making a lot of impact. They are putting the two sides of the entity together, the service providers and service requirers. So prediction was one theme, matchmaking is another theme. They are not really independent of each other. Matchmaking also requires prediction. So here is an example of a startup called Postmates, which has the goal of getting anything delivered in minutes. So like Uber has fleet of cars with drivers registered on the Uber app, Postmate also has a fleet of couriers, currently about 15,000, who can deliver goods locally. Huge amounts of data are gathered and subject to analytics to reduce the delivery time by drafting nearest courier personnel to pick items from specified shops and deliver, just like the Uber drafts its drivers. So you can see that there is a commonality between the way Postmates would service the demand and the way Uber would service the demands, even though the demands are different. The revenue of Postmate comes from commissions from shops as well as from delivery charges. And this is an interesting situation where small contributions in huge amount lead to an excellent proposition for monetization. And the methodology for this kind of startup activity is very regular and simple. Services register themselves with the software. People wanting service, they download that app, and matchmaking software pairs up the two sides of the service situation. They ensure first service, quality of service, and customer satisfaction. And they collect user feedback in spoken and written form. So feedback management, by the way, is an extremely important part of the story. These startups who are ensuring service delivery cannot be agnostic of people's opinion about them. They have to process the reviews carefully, and that requires both NLP and machine learning. Now, these startup activities, they survive off data, and now we have a new slogan in the world of connected devices: data is the new oil. This sentence was made famous by the British mathematician Clive Humby. So data plays a very important role. That is because it is important for the startups to focus on priorities and eliminate things which may be seemingly important, looks important, but data actually tells a different story. For example, suppose we have a translation service, machine translation service. It automatically translates documents, and we know that language contains all constructs, all kind of sentences, phrases can be appearing. But suppose the data shows that people mostly want to translate documents of their daily travel need, for example. It's a very, very specific domain, and the data shows that we want to translate mostly simple travel advisories. I've gone to a different country and I want to know where is the police station, where is the doctor, where are the markets, where can I find a cheap hotel. So those kind of statements are much more common than long sentences describing, let's say, some philosophical point of view. They also need to be translated, but the reality is that the most translation requirement is for simple travel situations. So that is the power of data. Data tells us what is important, what we should focus on. Even though many things are possible, only a few things are probable. That is the difference between possibility and probability. So now India's perspective on data is extremely happy. India generates huge amount of data, consumes huge amount of data, and all these data have to be exploited in an IoT situation, which is, for example, operating in India. India has a tremendous advantage compared to any other country because it is data rich. So here are some statistics. 462 million internet users exist in India, and that's 34% of the population. Global average is 53%. Even though the average is lower than the global average, the sheer number of Indian population makes even 34% an extremely challenging and useful proposition. 462 million internet users. Out of these 462 million internet users, 61% use internet daily, on an average 7 hours 25 minutes per day. 430 million users use internet from mobile. So this is what has made a very happy situation as far as data generation and data consumption is concerned. We can use internet from anywhere. Okay, the internet is not tied to a place. I don't have to find a desk, sit down on a computer and then access internet. That's not necessary anymore. I can be on the move, be anywhere and still access the internet. So 430 million users use internet from mobile, and every time they go into the internet, they consume data and they produce data. And 79% of the total web traffic is from mobile. 250 million Indian users are social media users, and that is 19% of total population. Global average is 42%. So even though the Indian average is lower than global average, the sheer number makes this percentage again a huge value. These 250 million social media users on an average use the social media for 2 hours and 26 minutes. There are 260 million WhatsApp users. Sorry for the spelling mistake there. It's WhatsApp, not WhatsApp. 53 million Instagram users. So all these are in the range of millions. They produce and consume huge amount of data. And probably the biggest data source, which is the biggest in the world, is the Aadhaar program, India's biometric ID program. There are 1.1 billion users, world's biggest database, and 30 million authentications per day free of cost completely. So for Aadhaar, it is an extremely happy situation. This is a humongous repository of data of diverse kind. So we consume and generate data through browsing, searching, emailing, online e-commerce, banking, credit card transactions, and all these adds to the oil, the new oil, which is data. And this oil really doesn't get depleted. It goes on increasing because of people's activities. And these activities, we understand, are orchestrated through devices that we use: our phone, our fan, refrigerator, car, washing machine, vacuum cleaner. All these are devices which we make use of, and once they are on the IoT framework, on the platform, they again in turn generate data and consume data. So the question is, what do we do with the data? This is where machine learning comes into play. The data by itself is not useful, it requires processing. And when we bring machine learning to process the data, we have to exercise wisdom. We have to be wise when to and when not to learn. I have a favorite example of mine, which I'll take up in 2 minutes. Data is really the new oil, and the central purpose of user data is profile building, learn the user's likes and dislikes, predict to and influence the user opinion to. So we can predict users stand with respect to anything, and we can influence that opinion too, which happens, for example, in polls in elections. So I was once in a conference in Vietnam, and from our hotel there was a sightseeing visit to a place of attraction called Ha Long Bay, and my hotel was called Chalcedony. So at the time when I used maps.google.com, I found that under that traffic condition at that time, it will take me about 3 hours 28 minutes to go from the hotel to the place of visit. Now, how does maps.google.com compute this time? Is this rule based or machine learning based, or is it deep learning based? Let's investigate a little more. We know that the time taken to go from one place to another would be the shortest time would be shortest path divided by the average speed of the vehicle. This is an extremely simple, clean application of speed time distance equation which has been in existence for maybe thousands of years. So this simple rule that time is equal to distance by speed, that has been crystallized after many years of empirical observation. And this is now a common knowledge which we can use every day. This knowledge need not be learned from the data applying machine learning. No. So this equation I need not learn. I know it, okay, from many centuries of actual experience. So the time to go from one place to another in ideal condition where there is no traffic, the whole path is for myself, is distance by time, is speed, distance by speed. But now enters traffic and makes the world chaotic. So time taken would be ideal time plus traffic time, Ti plus TTR. Now we know how difficult it is to model the traffic. If we could model the traffic accurately, then it will give us a function ftr which will return a value, and that will give me the time under the traffic condition. So ideal time plus TTR will give me the time which I'll need to reach from one place to another. But traffic is not difficult to model. If we knew how to model traffic, then it will be a clean rule-based system. I don't have to apply machine learning. I don't have to go to data. When the phenomenon is understood and expressed, the rules are necessary and sufficient. But when the phenomenon is not understood, there is a lot of variability, lot of uncertainty and surprise, then we have to make use of machine learning on data. This is the only thing we can do, and nothing else will work really. And we learn a model from the data. This is typically done through maximum likelihood estimate, which is also very appealing philosophically. All it says is that if we can train a machine on the available data, we can hope that this machine will also work well in future situations when unseen data arrives. So this is a philosophical proposition, it's a philosophical stand which has been empirically verified. We learn or we apply machine learning to create systems which indeed work well. So to go back to the Chalcedony Hotel to Hang Law Beach example, going from the hotel to the sightseeing place, we know how gradually maps.google.com gives us more and more accurate prediction of the time we will take. The system becomes better and better. How does it become better? Because it accumulates data. So it can predict at 4 p.m. the time that I'll take versus the time that I'll take at 9 a.m. or at 6 a.m. or very late at night at 1 a.m. for example. It can predict all that because it has seen actual experiences. Seen the actual experiences of people going from one place to another at various times, and it just makes use of this data. Okay, and without data, it will simply be a uh, case of hypothesizing, dreaming, or making unrealistic predictions. So data, 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 which is the most important entity in an AI IoT scenario. So data gives rise to model, and that is called machine learning. We produce a model that fits the data, and only that is the work that we can do. We cannot do anything else. We can fit a model to the data, and this is called maximum likelihood estimate, and that produces good behavior in unseen situations. And machine learning can be very simple to very sophisticated. We can have table lookup, which is also a kind of learning, by the way. It's called rote learning, and most of the learning in life is of this nature. Okay, even the machine learning is a very fascinating field with sophisticated techniques, but the reality, the data tells us that most of our learning is of rote kind. We simply retrieve a pattern and store it in our mind to use it later. That's all. So this is like table lookup. It's a very, very powerful form of learning. We cannot disrespect it. And the other end of the spectrum is a very sophisticated mechanism called deep learning, where you have multiple neural networks, large number of neural network layers, and information flows from layer to layer, from the input layer to the output layer, and then there can be backpropagation, softmax, uh, attention mechanism, long and short-term memory, all these sophisticated techniques which makes this learning effective and highly accurate. In between is statistical machine learning. An example of that would be graphical models or support vector machines. This is a spectrum which is worth remembering, going from table lookup through statistical learning to deep learning. Deep learning is the paradigm of the current scenario. But all of them actually work on data and create models which fit the data. So I would like to summarize the points from the maps discussion, that is how a trajectory is found from one point to another. The key lessons are we should learn those things which we do not know. Do not know is in red to say that there is no point learning what we already know. There is no point learning the equation of time as distance by speed. We know this already. And we have to learn by observing, learning from the data. We learn by maximum likelihood estimate, and this is the predominant modus operandi. And why we're spending so much time on discussing these highly fundamental points, simple but fundamental points, is because of the fact that artificial intelligence has to make use of machine learning. Without learning, there is no intelligence, and the IoT platform has to become intelligent by making use of AI techniques, machine learning techniques, language techniques, vision techniques, and so on. So it is important to have a good understanding and perspective on machine learning. Now, coming to the nature of IoT, thinking a little more deeply about it, we do see that there are many applications on personal front, industrial front, and government front. Government is interested in smart cities, intelligent traffic systems. Traffics are very, very problematic situations in big cities, in urban settings. Environment needs to be conserved. Disaster warning should be given. Defense should be unmanned eventually. Garbage monitoring has to be done. Garbage is becoming a menace for all metros. So government definitely is concerned with these large questions and important questions. In industrial settings, we need smart buildings, buildings which understand who is coming in, who is going out. Supply chain should be automated. Fleet management should be done efficiently. Products should be tracked when they are shipped. A courier company would like to know where the package is at this point of time. Industrial safety is important, for example, in mining situations. Emergency response systems are required, for example, in process control systems, or suppose a person is stuck in the elevator and emergency response is required. Vehicles need to be smart. There is a lot of work on autonomous vehicles which can navigate the roads without any driver. On the personal front, we need smart homes where the moment I come in front of the door opens, and maybe a robot comes out greeting me, please come home. Then I sit on the chair and another agent comes with a cup of tea. This is smart home. The air conditioner automatically adjusts the temperature. The fan begins rotating. The refrigerator produces the daily vegetables I need for cooking, for example. All these are extremely fascinating scenario, but they are not unrealistic. They will happen. The routes have to be smart, energy consumption has to be efficient, safety should be ensured in vehicles, disease management and health monitoring should be done, entertainment should be smart, shopping recommendations should come, movie recommendations should come. All these are IoT's goals, and IoT is very much on the way to achieving all this. So when all these things happen, our life changes, and we see that the life is changing because of AI and IoT interaction. We cannot live without making use of devices, and we want the devices to understand ourselves, be intelligent. So the components and functionalities, they actually implement a machine-to-machine ecosystem. The four fundamental layers of IoT are sensors, to collect data from the devices, communication, where data is aggregated across many devices. Computation involves processing of data, which is high volume, temporal, and there is a lot of redundant data. And finally, a service is provided, which is at the layer of application, and this requires context detection and learning. Now, AI, it really enables IoT. IoT, first of all, provides a sensor and device gathering. They are connected to each other in proper, meaningful way. But what can you do on that platform? That is what AI brings in. Okay, AI increases the power of this hardware. It decreases cost of operating the whole platform. Now, the reason why AI and IoT have come together is because of decreasing cost of CPU, memory, and storage, convergence of IT and operational technology, advent of big data, cloud, and fog, increasing device proliferation, decreasing the cost of megabits, increase of venture capitalist spending and investment. All these very happy factors have all come together really to have this powerful AI IoT combination. AI also crucially depends on data science, and data science is really a hierarchy of needs. We collect data, store data, explore data, aggregate data, and learn from the data, which requires optimization. We also transform data, we label the data, and all these are our day-to-day activities. We do not even notice that we are doing all this really. As you are listening to this lecture, you are mentally processing the information and already forming an opinion about whether the lecture was useful, was interesting or not. So you're labeling the lecture material also. And in this interaction between me and you as listeners or audience is also producing data and processing data. Now, AI, machine learning, and IoT indeed touch human life. Machine learning has broad potential across industries and use cases. So, all the domains that are touched by IoT and AI are indeed all the aspects of life itself: agriculture, finance, automotive industry, healthcare, consumer, manufacturing, telecom, energy, media. Think of anything that is touched by AI and IoT now. So high priority items are identifying fraudulent transaction, personalized crops to individual conditions, personalized advertising identity, and so on. So if we plot volume of the transactions against impact score, we can take different AI IoT application and place them appropriately in this two-dimensional space as per their priority. And there are many startups now which are making use of AI. AI is a very attractive proposition for startups because the entry barrier is low. All you need is data, huge amount of data, and choose a particular machine learning technique from the library of techniques and apply it on the data. And since AI is really entering all aspects of life, startups also are in no dearth of problems that they can work on and create impact as well as make money. AI startups in healthcare. Healthcare is a very important concern for all governments, and we have to have cheap and highly effective healthcare system. So AI is making a lot of difference to healthcare. In India, healthcare and AI synergy is important. There is huge shortage of medical professionals who can provide good advice and good treatment, and most of them, for professional reasons, are concentrated in urban areas, in metros particularly. However, the healthcare need is there all across the country, and in remote villages, remote locations, there are diseases, there are patients who need attention with respect to their medical condition. And doctors sitting far away can make use of the IoT to reach out to the student and provide advice. If you have seen the papers now, because of 5G and because of excellent image processing, doctors are able to advise on performance of surgery at a far apart place. So all this is becoming possible because of different technologies, AI, and I must say IoT. Now, an important point here is the notion of standardization. All kinds of claims are coming about usage of AI. There are startups, industries who are making use of AI, but the claims also are not many times not really authentic, and that demands standardization of AI to really verify how much of AI is truly being used. Now, data plus ML is available in plentiful supply, but they need sanity, they need standardization. So recently, Ministry of Commerce under Bureau of Investigation of Standards has created a platform called LITD 30, which is the mirror of International Standardization Committee of AI called SC42. And Indian government has created this committee, and I am the chairman of this. The standardization will play a very important role in verifying the standards of systems and the claims with respect to artificial intelligence. Now, this committee has to interact with all facets of life and the world and come up with standards to verify AI methodology used in the system. So the committee consists of IISCs, IITs, Ministry of IT, Computer Society of India, and top industries like TCS, Google, IBM, Intel, Microsoft, and so on. And there is another set of committees which has been created by Ministry of IT, Platform and Data for AI, Cyber Security, Technological Mapping, Leveraging AI for National Missions, and so on. So India's AI standardization effort, as already said, is a part of the international effort. And the first meeting took place in March in Delhi, discussing the scope and diversity of coverage. We are meeting very soon again in November at IIT Patna to discuss this standardization effort. So AI standardization is a new and difficult scenario. In civil engineering, bridge and road standards have emerged after many years of working on civil engineering problems. Indian AI initiative is driven mainly by what are called line ministries. The Ministry of Communication, Ministry of Power, Ministry of Education, all of them are now interested to exploit the power of AI, and Bureau of Indian Standards therefore has this mandate that AI standardization should make this proposition feasible for all ministries and all activities. And especially in the consumer space, the AI Standardization Committee should formulate standards so that claims can be verified. Here are a few examples. If a company says our washing machine uses AI, then we should give a set of standards or tests involving cloth, texture, color that the software must satisfy. The power grid in the campus is intelligent. If there is such a claim, then again our standards should verify that claim in terms of self-correction of circuit failure, load imbalance, and so on. If some company says we have created an automatic translation system, then the software should meet the standard of sentence length, phrase complexity, lexical complexity. If a company claims that our drone can automatically count the number of apples in an orchard, then we have to give standards of light condition, plant color, etc. So standards should guide the test suite construction, and the standardization should be application independent. So the activity will be in creation of interoperability, architecture, data platform, and evaluation standards. Now I'll draw some conclusions from the discussion that has happened. We see a new world order now. There is trinity of data, technique, and idea. Here there is huge opportunity for people with ideas because, as I'm repeating, the entry barrier is low. The data is available in plenty from many different domains. There are techniques to deal with this data, and the cycle of data application and more data is a steeply ascending gradient. So Uber uses the data to provide the service, but in the process also collects more data. So it goes on getting more and more benefit from the data that is accumulated. So it is providing service and at the same time improving its performance. Now Googles and Facebooks and Ubers, they are the haves. They will have access to unimaginable volume of data, and therefore their power will be enormous compared to entities which have less access to data. Now there are some startup priority areas. There are drones, especially for agriculture, like counting of fruit, sprinkling pesticide, machine learning applied to efficient supply chain delivery system, anomaly detection in loan disbursement, judicial situation, better traffic management, multilingual education platform. Then architecture and hardware for superfast processing, GPU, main memory. NVIDIA, for example, is in the hardware space, Intel also, and it is their platform which are giving power to AI problem solving. Education, in education one can have a living book like scenario. The book, when we read the book also reads us and tells a system whether we are really understanding the material. Is the student bored? Is the student finding it very complex to understand the concepts? Voice assisted chatbots are a reality, and Amazon Alexa, Google Assistant, Apple Siri, these are examples. Banking, tourism, insurance, judiciary, everywhere we have voice assisted chatbots now, and they carry out dialogue, and that is where natural language processing technology involved. The chatbot also should understand sarcasm, understand sentiment, and these are not in one language, multiple languages, and they have to be multimodal. They should see our facial expressions, body language, and so on. Language technology for social science is very important. It's called computational social science. For example, one could study the power equation, any kind of racial discrimination that should be apparent from the data. Personality reconstruction, this is a very important problem for missing person identification, terrorism containment, and so on. Sentiment and emotion tracking of stakeholder is so important for service providers. Amazon, Flipkart, they need to know what is the opinion of the people who use their service. Legacy data analytics is important. There are companies like Accenture and NTPC who have collected huge amount of data over the years, and they require processing and collecting knowledge from them. So that's a priority area. Remote consultation I have already mentioned, that can happen not only in medical but also legal and troubleshooting domains. I myself saw a system called Swift Geo, which creates drones, and they aerially detect any kind of crop anomalies. So they have created agricultural modeling and crop indexing for an area. So this is a system which drafts drones to do various kind of useful agricultural tasks. Now, in this scenario, of course, job displacement can come, and people who are displaced because of AI should be reskilled to take up more sophisticated jobs. So this is a new age of AI and ML, and this is captured by this equation: deep understanding is equal to shallow understanding plus big data. So understanding comes from academic pursuits, modeling, investigating deeply a research problem. And the data is consumed by startups. Data is also created by startups. So this is a very, very happy situation in today's world where AI is being applied across domains, across fields. AI is sitting on devices which are connected together to form the IoT platform. And machine learning is being used as a technique, and the data is in the form of image data, language data, which is where computer vision, speech, language processing technologies are involved. So this is the summary, and I would like to thank you for your attention. We would say that AI IoT is a very powerful platform which is transforming our life. Thank you.